Fine. Okay. Today we are going to start network theory, which is very, very important for your GATE exam as well as for AE or any exam if you take. It may be RRBJE, it may be for IES, it may be for GATE, especially for EC and electrical students who are preparing for this. This is the subject, it forms the base. It is the basic subject which is required for every other subject. It may be for electrical machines. If it is double E students, electrical machines, power systems, power electronics, for all these things, network theory forms the basis subject. And even for ECE, no need to tell, it's everything is interlinked with network theory only. So today we are going to start it. I'm going to tell each thing, how to do, what to do, every problem I'm going to solve in the class. In classroom, I'll give you time to solve. You try and tell me the answers, everything. It will be like a virtual classroom. It is not like it is going something online and what will be learning. Don't think anything. It will be like virtual classroom only. Okay. If you are having any doubts, please ask me immediately. I'm going to tell you everything. Fine? Clear? Yes. Okay. Myself, Venkatesh. I have cleared GATE 8 times. I have selected in DRDO, ISRO, Railway JE, SSC JE, and other state level exams, PSUs. But my passion is teaching, so I'm into this field. And I don't want to share, I don't want to waste more time. We'll get back into the topic. Yes. Today we are going to discuss about network theory. This is the subject where double E students will be getting around 8 to 10 marks. And if it is ECE students, you will be getting 10 or more than 10. If it is instrumentation students, anybody who is writing, he will be getting more than 10, that is around 12 to 13 easily. And this is a subject, if you are not perfect enough, if you don't know also, don't worry, I'll tell you from the basic. Even if you have not at all attended the classes in your BTech or BE or anything, don't worry, I'll be telling from the basic everything. The only thing I require from your side is concentration. That is the only thing. No need to write any notes. I'm telling you before only. No need to write. Just listen what I'm telling. If at all I'm giving some problems, please solve it. That's it. Running notes is not required. Anything is not required because everything will be there in this PDF and I'll be sharing this PDF to you. So you can learn from this also. Done? Clear? Yes. What will be the syllabus? Syllabus is basics of network analysis. Here we are going to learn KCL, KVL, nodal analysis, and mesh analysis, and how to solve different type of resistances given, how to solve the circuit. If it is series, you will be telling it will be added. If it is parallel, if two resistors are in parallel, R1, R2 by R1 plus R2. But if there are combination of different elements, it may be series, parallel combinations, how to solve quickly. Because in exam, nobody will check you how you are doing. They will just check what is your answer. That means if somebody is telling, for example, if you take resistance of 5 ohm and 2 are connected in parallel, the answer is 2.5. If you're directly getting the answer and ticking also, it is fine. If somebody doing the problem conventionally, he will take some 2 minutes time, he will also get 2.5. But the thing is, who is telling quickly, he will have more time to solve other problems. Somebody who is taking time, he will kill this time in this because you will having limited time in GATE. 3 hours of time, you have to solve 65 questions. If you are taking for simple questions also more time, then it's of no use. So I'll be telling what tricks you have to apply, how you have to solve, which method will be better, everything. Done? Clear? Okay. And this is the most important subject. This subject forms the most important, because in this chapter only you will be learning all the basics, and from this you will be getting around 2 to 3 marks. 2 to 3 marks you will be getting from here. And after this, DC theorems. In this you will be learning superposition, Norton's, Thevenin's, and Mach's power transfer theorem. This is the These are the topics which are there. Maximum power transfer theorem. These are the topics there for your gate, and even if it is for TNEB also. And next we are going to do two-port network. In this we are going to study about Z parameters, Y parameters, H parameters, G parameters, ABCD parameters, inverse ABCD parameters. Around 6 types. Okay, types of parameters we are going to see, and how quickly we can do. If somebody is asking Z parameters from a circuit, how we have to do, that is also very important. And this, it is very, very important. Minimum 3 to 4 marks you will be getting from here. This is minimum from transient analysis. I'll be telling you, many will feel difficulty in solving transient analysis, but no need to worry. Just simple steps, if you apply, you can solve anything. Just 3 to 4 steps will be there. If you apply those steps, it's done. No need to worry, oh, this is that kind of a topic. In my college days also, nobody can answer. Don't think in that way. I am there for you. And next, we are going to see AC analysis. In this, we are going to discuss how to solve when AC supply is given. Here we are going to see DC theorems. Same theorems will be applicable here, but here we will be giving AC supply. When AC supply is giving, how inductor is behaving, how capacitor is behaving, what kind of energies are saved, how we are going to solve it. All these things we will be doing here. Done? And also about resonance we'll be discussing. This is also a important topic where it will get, these are the minimum marks which I am telling. It is not like you will be getting 4 marks. You may get 4, 5 also sometimes from transients, because if you are thorough with this, if you want to be thorough with transient analysis, first you have to be thorough with basics of network theory. If you are not thorough with the first chapter, going forward is of no use. So if you are having any doubts, please ask me there only. No need to worry. Done? Okay. Oh. Magnetically coupled circuits. After that, we are going to see this. If mutual flux is interlinking, flux from one coil is linking with the other coil, how does it behave? If it is in addition to the self flux, how it will be behaving? If it is in opposition to the self flux, how it will be behaving? That we'll be seeing in this. And last is three-phase power. And three-phase circuits is not there for EC students, gate syllabus. It is there for electrical students. Done? Yes? Is it clear? No need to write notes. The only thing I required is attend daily live classes. Don't think daily live classes, please attend. Don't think that I'll be watching the recorded classes, because attending live and recorded is why it is different, because you can't ask immediately if you are having any doubt in recorded. If it is live, you can ask immediately. You can stop the lecturer, you can stop the educator who is teaching you, and you can resolve it then and there only. If you are having any doubt, you can't even proceed further. So that is the important thing you have to do. Daily you attend daily live classes. If at all some odd cases, you may be having some urgent work. So in that cases, we can't do anything. In that case, you can attend recorded lecture, but don't miss recorded lectures. That is the first point you have to do. Next, whatever questions I'm giving, okay, questions, homework questions, please solve it. Homework questions, if you are having any doubt, you can ask me. I will tell you in the next class, but try to solve it. If you are having doubt, then we can see in the later on. Done? Okay. No need to write any handwritten notes. Everything will be available. You can get the PDF. Whatever I'm writing, same PDF will be shared. Done? No need to write running notes. No need to write. Whatever problems I'm telling, if you solve it, we can proceed. Done? Is it clear? Okay. Now, what is the syllabus we are going to see? Syllabus is network analysis, network elements for double students, ideal and 1 minute. You are able to see full screen or side something is coming. Please tell. Please, you are able to see full screen or in PPT some side it is coming something. Something is coming, sir. Okay, Lavanya. Okay, 1 minute. We'll solve it. We'll solve 1 minute. Now is it fine, right? It is fine. Yes. Okay. Now the syllabus for electrical engineering, get syllabus is network elements. I told you we are going to see KCL, KVL, node and mesh analysis. These are the most important, and we are going to see what type of sources, what is linear elements, passive elements, types of elements, sources, resistance, inductor, capacitor, everything. And after that, DC theorems, types of DC theorems, transient analysis of DC and AC networks, and sinusoidal steady state response, two port networks, balanced three phase circuit, star to delta transformation. This we will be discussing in basics only. Basics of network theory chapter only we are going to discuss star to delta. Okay. And no graph theory. Done. Okay. Now if we go for gate ECE syllabus. In this, there is no same syllabus, but except no three phase circuits. Okay. No magnetically coupled analysis. No three phase circuits, no coupled circuit. CKT means circuits. Fine. Okay. And even for instrumentation also, no three phase circuits. Remaining everything is same. Name may be different, but everything is similar only. There is no need of, oh, this name is different. Don't think anything. Everything is same. Yes. I told you how many marks you are getting, how you are going to do. The only thing I need from your side is concentration. That is the one thing I'm expecting from you. That is it. Now we'll go from, I told you, from basics. So we'll start from basic definitions. What is charge? What is this charge? Charge is something, it is a inherent property, fundamental property of matter, by which, by losing or gain of electrons, it is measured generally in coulombs. If you lose an electron, then we'll be calling it as positive charge. If you gain an electron, we'll call it as negative charge. Okay, this arrow mark. Done. And what is the charge of one electron? See, charge on an electron is equal to 1.6 into 10 power minus 19 coulombs. This is very important if you are going for state level exams. Charge on an electron is equal to, this is for one electron. Okay, if he is giving, for suppose he is having 10 lakh electrons, then what will be the charge? Means 10 lakhs into 1.6 into 10 power minus 19. Fine. Then charge on a body, how it will be quantized? Charge on any body is equal to Q is equal to number of electrons into charge of one electron. Done. These are the most important things. Please, if I'm telling some numbers, if you are able to write, it's fine. If you are not able to write also, it's okay, it will be there. Done. Now we'll see what is charge, what is bounded charge, what is unbounded charge. We'll see. Now we'll see what is free and bound charge. Now you all know, you might have studied in your 10th inter, everywhere +1 +2. This is a nucleus. In nucleus you will be having neutrons and protons, and electrons, it will be revolving around this. Yes, and there will be a electrostatic force of attraction. There will be a electrostatic force of attraction between this. Let this be an electron. It is revolving in an orbit. Why it is not going out? It is revolving only in that circular path, in that orbit. Means it is having an attraction with the nucleus. That force is called electrostatic force. Okay, when electron revolves, when electron revolves around the nucleus, in fixed orbit, I'm taking here only one orbit. Okay, just for understanding, don't tell that which kind of it is sodium or hydrogen or any other thing. Okay, just for example I have taken, when electrons revolve around the nucleus in fixed orbit, then it is bound to nucleus. I told you the same thing I'm writing. It is bound to nucleus by electrostatic forces. By electrostatic forces. So if it is bounded by electrostatic forces, it is called as bound charge. Now when we apply, there is some force of attraction, electrostatic force of attraction. If we apply more force than this electro force of attraction on this electron, okay, if we apply more force than electrostatic force of attraction on this electron, then the energy will be more than ionization energy. Then this electron will come out of the atom and can take part in current conduction. It will become free charge. Okay. When here I'll write, when we apply higher force, then electrostatic force on electron. Okay. Or provide energy more than ionization energy. Then this electron will come out of the atom and take part in current conduction. Then electrons comes out of atom and can take part in current conduction. Right? You all know what is current. Current is nothing but it's a flow of electrons. Flow of electrons you will be telling. So what is flow of electrons? That is what I am telling. It is not like if an atom will be having many electrons, it doesn't mean that all the electrons will be participating in current conduction. It is only those electrons which we call it as free charge or free electrons. Only those electrons will be participating in current conduction. Okay? When this current can flow? Yes. Current is nothing but rate of flow of charge through a cross-sectional area. This everybody knows. I is equal to rate flow of charge and through a cross-sectional area. It is measured in amperes. I is given by I is equal to dq by dt. Q is nothing but this electric charge. Okay, done. Done. Now we'll see. Yes, we'll see what happens. For suppose let this be a conductor. Let this be a conductor. You are having a charges, that is free electrons you are having. Okay. Now, if you apply electric field in this direction, okay, if you apply electric field from left to right for suppose, then this free electrons will travel opposite to this electric field. The free electrons, these will try to travel in opposite to this electric field. Free electrons, these you might have studied in your analog electronics, but even though just for revision purpose, I'm telling, fine. Free electrons travel opposite to the electric field applied. This is called, these free electrons traveling or flowing is called current flow. It is called current. You can write here. When electric field is applied, then electron, when electric field is applied, then electron experiences force opposite to electric field. Electric field is applied, then electrons experiences force opposite to electric field. This force, it will be given as F is equal to Q into E. Q is charge, and charge of an electron is, we have already discussed, and this force will be opposite to, force is opposite to electric field. Fine. Now, what is current? Current means rate of flow of charge. When electric field is applied, electrons flowing opposite to electric field. Now, these electrons are flowing. It's fine. But how much it is flowing? What is the rate? Rate of flow of charge. That means per second how many charges are flowing? For suppose that is called as current. How much speed it is flowing? That is the exact meaning. Done. I will be equal to dq by dt. This definition already I have given in PDF. No need to write here. Rate of flow of charge per unit time. Done. Yes. Now what will be the direction of the current? Can anybody tell? Direction of the current we always take from positive to negative. Then why the electrons is flowing from negative to positive? Why can't we take this as a direction? Actual direction is from negative to positive only. But before the invention of electrons, scientists assumed that the current is flowing, it is flowing from positive to negative. But later on, some scientists found that the current is flowing only due to electrons, and these electrons are flowing from opposite direction to the electric field. But as it is already going through the world that current is flowing from positive to negative side, so it is let it going. It is not like it has changed. So that is the reason why we call it as a direction of conventional current. Direction of conventional current. This direction is in the direction of electric field, but actually the direction will be from opposite to electric field. Fine. Is it clear? See, if you take this as a conductor, if you apply the electric field, let this be point A, let this be point B. Now electric field is applied. It is applied in this direction. You can see this will be positive, this will be negative. Yes. Now the conventional current flow is from this. It is flowing from positive to negative. This is conventional current direction. Conventional current direction or conventional current flow. But actually, opposite to electric field applied, electrons are flowing. Electrons are flowing opposite to the applied electric field. Means in this direction it will be flowing. Fine. This is flow of electrons. Okay. Then we came to know what is charge, what is current. Now we'll see what is voltage. Voltage is the electric potential difference between 2 points. It is measured in volts. It represents the work done per unit charge. Okay, now we'll see. I'll explain everything, no need to worry. Here I'll tell you. When a charge is moved, let this be this, when not having a space. I'll explain here. Okay. Now, if this is the electric field, okay, this is the electric field. Now, there is a point charge here. Let it be this as A. Now, he has to move to point B. When charge is moved under the influence of electric field, then work done per unit charge is potential difference. Now this, it can move like this and go, or it can go straight, or it can go in other direction. It doesn't matter in which direction, what path it is following. It is the only difference is work done from A to B. How much work done to move the charge? That is called potential difference. Done? Clear? Okay. And this, it will be independent of the path. I told you already. What is EMF? What is potential difference? Anybody? What is EMF? What is potential difference? Please. Can anybody tell what is EMF? What is potential difference? Yes. What is EMF? What is potential difference? Arshaya, Lavanya, please. Please reply. Whatever you know, you please reply. No need to think that if it is wrong, what will happen? Because if you are doing something wrong here, you will not repeat the same mistake in your exam hall. If you are not telling anything here, then you will repeat the same mistake there. Yes or no? So try to answer how much possible. Please. Class should be interactive, so please answer. Please, please, please. Voltage definition is given. I'll write it clear here. When a charge, please think and tell me by the time. When a charge is moved under the influence of electric field, then work done per unit charge is potential difference or voltage. You can call both. That means VB minus VA will be equal to work done in moving charge A to B by charge Q. We can also tell it as minus integral A to B E dot dl. Yes. You got any answers? EMF is something, the energy supplied by a source per unit charge. Potential difference means consuming one. Okay, if it is a source, you will be telling EMF. If it is something like resistor or something, resistor or any other thing, if it is consuming, if it is a passive element, it can't supply energy, then you can tell voltage across that is potential difference. Done. Okay, now you got what is the difference? Okay. Okay. We'll see one or two problems. Please do this. I'll be giving you one problem, basic problem, not more. Charge Q is equal to 4 into 10 power minus 4 into 1 minus e power minus 250t coulombs. Okay, now obtain the current or find the current at t is equal to 3 milliseconds. What will be the answer? Find the current is telling. Current, how you can find when charge is given? Current I is equal to dq by dt. Yes, whatever d is given, you differentiate now this. This is constant term. You can see this 4 into 10 power minus 4 is multiplying with 1 and also this e power minus 250t. Okay, you write it separately first. I'll tell you. Q is equal to 4 into 10 power minus 4 minus 4 into 10 power minus 4 into e power minus 250t. This is Q. Now, if you differentiate, this is a constant term. Fine. Differentiation of constant. Differentiation of a constant k is equal to 0. Fine. If you are having some function as a function of t, then you can write that constant as it is. But there is nothing, only a constant is there, then differentiation of constant is equal to 0. Now what will be remaining? Then dq by dt, if you do dq by dt, then what will be the answer? This is already 0, so minus 4 into 10 power minus 4 into e power minus 250t. So e power minus ax is equal to minus a into e power minus ax. You can write that. Differentiation of e power minus ax is equal to minus a into e power minus ax. So you write it. Minus a is minus 250 into e power minus 250t. Okay, now what will be the value of current if you do this? This is minus into minus will be plus. Yes, then you do this calculation. If you do, then it will be finally 0.1 into e power minus 250t. Now you substitute at t is equal to 3 seconds. At t is equal to 3 milliseconds. T is equal to 3 milliseconds. What is the value of current? Okay, value of current will be finally, if you substitute, then it will be 47.27 milliamps. Fine. This is a basic question. This is very, very basic question. Very basic. Next, we'll move to power. We have seen what is current, what is voltage. Now we'll move to power. Power is something, rate of change of energy is called power, and it is measured in watts. Whatever work done is there, it is stored as energy. And this energy, what is the time rate of change with respect to, for example, if you are doing some work of 100 joule, but for how much, in what time you have done, if you measure that, it is power. That is it. So P will be equal to then dq by dw by dt, and you all know P is equal to vi. You will tell that how you got from dw by dt, only you got v into I. And instantaneous power means at a particular instant, if you want to measure, then that is called instantaneous power. So at that particular time, what is the voltage and current, if you multiply, it is called instantaneous power. And these instantaneous powers generally will be used to find power in AC analysis. Okay, it is represented by power P of T. Done. Now we'll go into this. This is the most important thing. Please write this. Write this. When current enters positive terminal of an element or leaves negative terminal of an element, then element is said to be absorbing power. Now you see, the current is entering from top to bottom. In this if you see, in this, it is entering from top to bottom, and in top what terminal is there? Plus, and in bottom negative terminal is there. That means when the current is entering from positive to negative terminal, it is said to be absorbing power. Absorbing. Okay, this element, whichever element is there, it is absorbing the power. Now if a current is entering from negative to positive in this manner, then this is called delivering power. Delivering power. For example, if you take, what will be the example for delivering power? Simple thing is source. Source is something which is delivering the power, right? It is delivering the energy which is there inside. So sources are delivering power. And what is absorbing power elements then? Absorbing power means, which is absorbing? Resistor is an absorbing element. Yes, inductor is an absorbing element. All these kind of things which is taking the power, which is not capable of supplying, is called absorbing elements. Done. Very important thing. Please note this. Absorbing means from which direction is there. Delivering means from which direction to which direction is there. Please note this. This will be very important. Done. Yes. We'll see what is energy now. I told you already, work done is stored as energy. So work done on any element is stored as energy inside that element. It is measured in joules. When P is equal to dW by dt. I have told you this. Differentiation on one side. If you send to other side, then it will become integration. Integration into dt is called power. In that manner only we got this. Fine. It is not something you remember everything. If you remember 2 to 3 formulas, you can interchange everything and you can get the answer. And what is law of conservation of energy? You have studied from your class 5 or 4. Energy can neither be created nor destroyed. It can be transferred from one form to another. And here also same thing. If some element is delivering energy, that means some other element will be absorbing that energy. We'll see what is the elements. We will see what are the kind of questions also. Okay, the unit is joules. And finally, whatever delivering energy is there, the total delivering energy will be absorbed by some elements. So finally, if you see the net energy, delivering minus absorbing, you will be getting finally as 0. I told you, because you can't create it. So net energy will be equal to 0. Fine. Now you do this. Find the power delivered. What is the power delivered to an element? Yes, please. If you see this clearly, power delivered to an element at t is equal to 3 milliseconds he wants. So power is equal to, first he is asking power. So power is equal to, what is the formula? Power P is equal to V into I. Correct? Yes. Now he is asking what is the power delivered to an element at t is equal to 3 milliseconds. And he has given the current entering its positive terminal. Current entering its positive terminal is I is equal to 5 cos 60 pi t amps. Okay. Now he has given current and the voltage is also given, not in direct form. He has given V is equal to 3 into I. That means voltage is depending on current and we know the current value. So first we'll find for A. Here V is equal to 3 into I. So you write 3 into, what is the value of I? I is equal to 5 cos 60 pi t. So that means 3 5 are 15. 15 cos 60 pi t will be the answer for V. And but what he's asking? He's asking the power delivered. Power delivered means P is equal to V into I. V is equal to 15 cos 60 pi t into I is equal to 5 cos 60 pi t. Okay. Now if you see this, this is like cos A and cos A. Both are same. That means you can write it as cos square A. Right? And this 15 into 5, it will get multiplied. 15 5s are 75 cos square 60 pi t. Cos square theta, you can write it as 1 minus cos 2 theta by 2. Sorry, 1 plus cos 2 theta by 2 you can write. So 75 by 2 into 1 plus cos 2 theta means this 60 pi t you assume as theta. So it will be 2 into 60 pi t. Done. I'm writing every step clearly so that even if you open this PDF after 6 months, you have to understand clearly. That is the reason. Okay. Please be concentrated here. Now, if you substitute t is equal to, what he is asking, t is equal to 3 milliseconds, what is the power? So, at t is equal to 3 milliseconds, in place of t, you substitute 3 milliseconds, then the power you will get P will be finally 75 by 2 will be 37.5. And if you substitute here, it will be 1 plus cos 120 pi t means it will be around cos 0.36 pi. So finally you will get the answer as 53.466 watts. Okay. This will be the power. This is for A. And for B, he has given V is equal to 3 into di by dt. Now you have to differentiate the current. Now, what is the differentiation of cos 80 is equal to minus A sin 80. Okay, you write as it is. In place of A, whatever is there, you write it 3 into, yes, 3 into di by dt means what you will get? 5 is already there as a constant. What is A here? A is 60 into 5. Fine. After that, you have to put here, I told you, if you're differentiating cos, you will get minus sign. So minus 3 into 5, 60 pi into sine A is 60 pi into t, sine 80. Fine. 3 5s are 15. 15 6 are 90. So 90, 900 pi into sine 60 pi t. This will be the answer for V. V you got this much. Now P is equal to V into I. Now if you substitute this, what will be the answer? Minus 900 pi sine 60 pi t into 5 cos 60 pi t. What will be the answer? Can anybody tell? It is like sin A cos B. Sin A cos B formula is sin A plus B by 2. Sin A plus B is equal to 2 sin A cos B. But here only sin A cos B is there. So send 2 to other side. It will become by 2. So it is finally minus 4500 pi into sin 120 pi t. Okay. Now he is asking power at t is equal to 3 milliseconds. So at t is equal to 3 milliseconds, power will be equal to minus 6395.84 watts. Clear? This is how you have to find the power. Now, you please find for this. How you will do? Yes, you will do or shall I do? You need time? Please tell. Please reply. If you need time, I'll give you some 2 minutes of time. You can do and tell me. Please, please, please. If you want time, you tell me. I'll give you time. Yes, please. Please reply. Please, please. Please reply. Okay. We'll see here. What is the voltage source given? Yes, given the voltage source. What is asking? Is asking whether this voltage source will absorb power or it will deliver power. Absorbing or delivering, it will depend on whom? Yes, it will depend on in what direction current is flowing. In what direction current is flowing, if you are knowing, then that is it. We can get this answer. So here, absorbing, I'll write again here, absorbing power. This will be OB, sorry, means current flows from current flows from where absorbing means it will flow current from positive to negative terminal. If it is delivering power, current flows from negative to positive terminal. Okay. Yes. Now you see. I told you net energy will be equal to 0. Now this is 10 volts. The current you see, current if you see here, current is flowing from this direction from positive to negative. Then this will be, this 10 volts will be absorbing or delivering. If it is flowing from plus to minus, it absorbs. You can write it absorbs. And this current is flowing from positive to negative. So this also will absorb the power. It absorbs. And the same current you see here 3 amps is flowing, here 9 amps. It is flowing from, if you see properly, current is flowing from negative to positive. So it delivers. And here current is flowing from this direction from positive to negative. So this absorbs. So your answer is simple thing, it absorbs power. But absorbs means how much power we don't know. But here it is given option A or C. Because it is not delivering, so option B and D are removed based on these assumptions only. No need to do anything. Directly you can tell it is absorbing power. Fine. Now this, if you see this is going current in this direction, that is from positive to negative. So it delivers or absorbs? It absorbs power. Yes. Now you see here how many are absorbing, how many are delivering? Yes. How many are absorbing, how many are delivering? You see this? Everything is absorbed, only this is delivering, right? Everything is absorbed. Only this 16 into 9, only this is delivering. So, how much is the power here? Here the power P is equal to, how much is the power? 16 into 9. It will be equal to 144. PD I am writing if it is delivered. Fine. Here power will be equal to 10 into 3, 30 watts. Here it is PA. Here it will be PA, it is equal to 18 watts. Now this it is absorbing. We don't know what is it. PA is equal to 6 into Vs. And here it is absorbing. If it is absorbing, the power PA is equal to V into I, right? 6 into 8 is 48. Clear? Is it clear? Please tell. If it is clear, we can proceed further. If you see, I told you already, net energy will be 0 because how much energy it is delivering, same energy it will be absorbed. Energy is nothing but power by time, that is energy. So total power delivered will be total power absorbed here. P delivered will be equal to P absorbed. Here how much power is delivering, you can see it is 144. How much power it is absorbing here? It is absorbing 30 plus 18 plus 48 plus this we don't know. We have taken as PA. Okay, this PA Vs absorbed power due to Vs. Now if you send all to other side keeping PA power absorbed by the voltage source one side, then it will be 144 minus this will be 30 plus 48 is how much? 78. 78 plus 18 is 96. So 144 minus 96 will be equal to power absorbed by voltage source, and power absorbed by voltage source is equal to finally 48 watts. That means it is absorbing 48 watts. Clear? And also here one more thing, most important thing I want to tell is whether this it is absorbing power. I will also accept it is absorbing power. If at all in question he is giving only it is delivering power, no option of absorbing, then what you will do? Which option you can take then? Then that means here it is absorbing power of 48 watts. So you write this PA is equal to P absorbed is equal to 48 watts. This same thing we can write as same thing in P delivered, power delivered is equal to minus 48 watts. Clear? Same if it is absorbed, if it is positive, then if it is asking only delivered power by the same source, then you just find the power absorbed, then put negative sign. That will be the power delivered. If here 16 volts, here 16 volts, this is delivering power of 144. If he is asking what is the power absorbed by this 16 volts, then what you will do? You just put the opposite sign, you put negative sign, then it will be power absorbed will be equal to minus 144. Clear? Simple thing. Fine? Yes? Done. Now, how you will find this? Find the power delivered at t is equal to 0.8 seconds. Yes? How you will find? Power delivered at t is equal to 0.8 seconds. You know what is the value formula for power? Whatever is asking first, you write the formula for it. Then we'll see from there how we can do. Power P is equal to V into I. Done. What is the value of V here? What is the value of V? Here if you see properly, the current is flowing from positive to negative. If the current is flowing from positive to negative, then it means this is absorbing the power. It absorbs power. It is not the one which is delivering. It absorbs the power. Then if it is absorbing, how you can write how much it is delivering? Yes, please. How you can write how much it is delivering? P delivered, if you want, I told you already it is equal to minus of power absorbed. Done. Whatever absorbed power is coming, you put opposite sign. If you are getting this, you put other sign, you will get the answer. Now 5 into t square minus 2 is the voltage here. Right, same. 5 into t square minus 2. What is the current flowing? It is 5.1 amps. Now you will get power in watts. But what he is asking? He is asking the power delivered at t is equal to 0.8 seconds. So at t is equal to 0.8 seconds, what will be the power? P is equal to 5 into 0.8 square minus 2 into 5.1. This will be 5 into 0.64 minus 2 into 5.1. So finally, what answer you will get? What you are getting here? Finally you will get here negative. 5 5 is 25. 25 into 1.36. 25.1 into 1.36 will be around 34.68. 34.68 watts. Yes, this is the power. But if you see here, if you see in question, it is given current is flowing from positive to negative. It is not like it is flowing from negative to positive. It is flowing from positive to negative. What it is? It is the absorbed power. It is the absorbed power. So if you want delivered power, what you will do? P delivered is equal to minus into P absorbed. So it will be minus of minus 34.68. Then this is equal to 34.68 watts. This is the power delivered. What is option? Option D is the correct answer. Clear? Is it clear? Done. Okay. How you will do this? Yes. This I'm giving you as a homework. Okay. Please do this. Yes, it will be a little tricky, but if you understand the question clarity, if you understand the question properly, then this is easier question. This is a easier question, but you just understand how it is being done, what it is given in the question. Okay, I'll give you formula. E is equal to integral P into dt. Integration means overall area. If you are getting some square, what will be the area there? A square. If you are getting rectangle, then it will be area is equal to length into breadth. So you just draw the graph. I'm telling everything, you just do it. Whatever given in question, draw that in graph. Now try to find area. Mostly triangle or rectangle will be getting. So try to find that area and you add it. Integration is accumulation only. Accumulation means adding overall. So add those areas, you will get the answer. But time, you see, time should be in seconds. Okay, it is not like here it is given in minutes, so you are doing with that. First convert the time into seconds, then you go, you proceed with it. Fine? Yes. How you will find for this then? This is also your homework question. Simple, I told you net power is equal to 0. Here this is going current from positive to negative. Positive to negative means it is absorbing power. This is going from negative to positive here. So it is delivering power, this 80 volt. And this is 10 amps here, 8 amps going out. So how much current will flow here? 10 amps, 8 amps going out. Here 10, here 8 going out. Then here it will be 2 amps. Done. At a junction, I will tell you this, but you make this as a homework. I will tell you all these things. At what point you will be considering. At a point, current entering will be equal to current leaving. Okay, I'm telling here only. You please do based on that. Then this will be 15 volt will be delivering the power. So you find what will be the total power absorbed by the three elements finally. Now we'll go into the basic terminologies. Till now we have seen what is voltage, what is current, what is power, what is energy, and how we are going to find it. Then now we are going to see the terminologies. What is circuit? What is network? What is loop? What is mesh? All these things we are going to learn. Done. Now, what is circuit? Circuit, here if you read this statement properly, it implies a closed path. That is, start and end points are same so that current can flow. To flow current, you should have a closed path. To flow current, you should have a closed path. So start and end point should be same. So, so a circuit is a closed path where a current can flow. If you see this, is it a circuit? This, it is a circuit because if you start from this point, okay, if you start from this point, you can go like this and you can come back again here. So if you are going and coming back again without any break, that means it is a closed path. This is one closed path, this is one more closed path, this is one more closed path. You are having three closed paths here. Current always requires a closed path to flow. Now what is network? What is network? Network is a interconnection of elements where current may or may not flow. May or may not means if current is flowing, we are telling it is a circuit, correct? If current is flowing, we can tell it as a network also. We can tell it as a network or a circuit. But if current is not flowing, we can tell only that it is a network. It is not circuit. Fine. Having a closed path is mandatory for circuit, but closed path is not mandatory for network. Clear? Clear? Okay. Now you see. That means if these are the circuits, all circuits are networks, but all networks are not circuits. Fine. If you draw these diagrams, you will be knowing Venn diagrams, all these things. In your general aptitude, you will be studying. If you go according with this, all circuits are networks, but all networks are not circuits. Fine. Okay. Now we'll see what is node. What is node? It is a point at which two or more than two elements are connected in a network. 2 points when directly connected by a wire without any element in between, then it is considered as a single node. That means you see here, this is the best example. What he has given here, it is a point where two or more means minimum two should be there and maximum any number can be there. Minimum two means where source means it is element means it can be anything, resistor, capacitor, inductor, diode, voltage source, current source, anything, but some element should be there between 2 points. Now if you see, if you consider this point, okay, if you consider this point, from here you are having an element here, you are having an element here. That means you can call it as a node, correct? Now if you see here, here also one element is this resistance, one more element is this, so you can call this also as a node because two are connected, two or more is telling. Now if you see, we can call this as a node, this, yes, we can call it as a node, we can call it as a node. But you see this second point now, 2 points, okay, 2 points when directly connected by a wire without any element in between, without any element in between. If no element is there between 2 points, then it can be considered as a single node. That means this is a point. Yes, here also one point is there, but here no element is there. That means it is not a two nodes. We can consider it as a single node. Fine. Clear? Clear. We can consider it as a single node. And similarly here also, this is also one point where in between these 2 points no element is connected. So we can consider this as a single node. And if you see this bottom, if you see here, Then here, this is a point, this is a point, this is a point, this is a point. Yes, all four are points, but in between any element is there? No element is there. Then all these four will act as a single node. That means how many are there totally here? Here, 3 nodes are there. Clear? Is it clear? Done. Now, what is branch? Branch is nothing but it is something which is connected between two nodes. It is a connection between two nodes in a network. Here, how many branches are there? In between two nodes, how many elements are there? You can tell that as a number of branches. This is one branch, this is one more branch, this is one more, this is one more, this is one more. So totally 1, 2, 3, 4, 5. So 5 branches here. And what is degree of node? Degree of node means number of branches connected to a particular node is called as degree of a node. That means here you can tell if number of branches connected are 2, then degree of node is, it is represented like this. Number of branches is equal to 2, then degree of node is equal to 2. This is called as simple node. Okay. If degree of node is greater than 2, then we can call it as a principal node. This principal node we can call also as junction. That means we can tell if more than 2 branches are connected at a node, then we can call it as a junction. Not 2 or more than 2. That means minimum 3 should be there. 3 or more. If connected to a particular node, then we can call it as a junction. It is also called as principal node. Fine. Here, how many junctions are there? Here if you see at this point, this and this are single node. So one resistor, one more resistor, and one more resistor. So this is called as junction. And here 1, 2, 3, 4. So this is also called as a junction. And if you see here, one branch, that is voltage source, this is resistor, this is one more resistor. So this is also called as a junction here. Clear? Clear? What is the difference between node, branch, junction? Now, what is mesh? Mesh is a closed path in a network which starts and ends at same point and doesn't contain any more closed path inside it. That means, if you see how many closed path will be there here, this is one closed path. You can start from here, coming here. And if you see this is one more closed path. This is number 2. This, it will be 3. And what is telling? Closed path in a network which starts and ends at same point. That is fine. That is a closed path and doesn't contain any more closed paths in it. That is called mesh. That means if you see one more here, you can go with outer. I'm starting from this point, and if you trace from outer end, then this will also form as a closed path. You can see that I'm again coming to the same point. Yes, then this is also a closed path that can't be a mesh because he told already it doesn't contain any more closed path. If it is containing, then it is not a mesh. Only 1, 2, 3 are mesh. Then this outer loop, what we can call? We can call it as a loop. The outer one, we can call it as a loop. A loop is just a closed path in a network at which may or may not have many closed path inside it. Okay, that means here if these are the meshes, all meshes are loops, but all loops are not meshes. Done? Is it clear? If it is clear, we'll move further. Here, number of meshes, we can directly tell if you are having m is equal to b minus n plus 1. Okay, here b means number of branches, n means number of nodes. Clear? Plus 1. You can tell directly from like this also. These are simple ones, very important in your state level AE exams. And even for IAS, GATE also sometimes now basic questions they are asking, which many students will do wrong because they know how to solve circuits, but they don't know how to find these meshes. These are the basic things which they will be missing. But I don't want to take any sort of chances. I want my students to be 100% perfect when they are going for GATE exam or any other exam for network analysis. They should be 100% clear. Clear? Now, mesh is also called as a loop, but all loop can't be called as a mesh. I told you this outer one, you can call it as only loop, not mesh. This inner one will be a loop or a mesh. You can call any way as you want. Now, please tell how many number of nodes, branches, and meshes in the circuit. Please, if you see, this is one point. Yes, this is one node. This is one more. This is one more. This is one more. This is a point. This is a point. Yes. Now if you see, we'll denote it. Let it be A, B, C, D, E, F. Okay, let this. Now, how many number of nodes are there? That means here two elements are connected. So A is one node. Nodes A. If you see at B, B is one node because here three are connected. So two or more elements connected to a point, we can call it as a node. So B. C, at this point at C, two elements are connected. So C is also a node. At D, voltage source and this resistor is connected. So two are connected. D is also a node. And at E, if you see, this resistor and this is connected. That is also a node. And if you see this properly, E and F, this E and F, these are connected by a wire, not an element. So if there is no element in between, that means this is a single node. It is not a two nodes. So this is a single node. That means 1, 2, 3, 4, 5. Only 5 are the nodes. Number of nodes are 5. So n is equal to 5. How many branches then? Branches means how many number of elements you can see directly. Voltage source is 1. This resistor is 2. This resistor is 3. This resistor will be 4. This is 5. This resistor is 6. So number of branches is equal to 6. Number of meshes. Meshes, how you can find? Yes, number of meshes is equal to b minus n plus 1. It is equal to 6 minus 5 plus 1 is equal to 2. Okay. Otherwise, you can also choose the path. This is one mesh. This is one more mesh. 1 and 2. Clear? Clear? Okay. Then how many number of loops then? In question it is not given, but I am asking. How many number of loops? B is branches. M is meshes. How many number of loops? Loops is equal to 1. This mesh we can call, and also we can call it as a loop. 1, 2, and this outer one. D, A, B, C, E, D. You can form that as an outer loop. So totally 1, 2, and outer loop is 3. So total 3 loops. Fine. And from here, you do it as a homework. Fine. If you are having any doubt, you can ask me tomorrow, but you try to do. This is a very simple one. You try to do it as a homework. Now find the number of junctions here. How many number of junctions? This I'm giving you as a homework. Just see where they are connected. Junction means what I told. 3 or more than 3 elements connected at a point. I am writing the statement here. If you know the statement, it is very simple to find. Yes, fine. Now, find the minimum number of equations required to analyze this circuit. How many minimum number of equations? You know only mesh equations. So, this answer is not that. There is also one more, that is n minus 1. I will tell you when we are going further. Okay. This I'll tell you later. You also take it as a homework. All which I am giving as a homework are very simple. If you just spend 10 minutes maximum time, you will complete all these 5. All these 5 questions in 10 minutes you can complete. I am guaranteeing you. But only thing is required is how much you have understood in this class. If you have understood, it is very simple. This you try to do. What answer you are getting, you tell me. I will tell the correct answer on what basis. Here I told you how many number of meshes. On that only you can tell number of equations. But we'll see there is also one more equation where you can find that in the later class. From there you can get the correct answer. Done? Is it clear till now? Till now, is it clear? Please reply. If you are having any doubts, please tell me. Please. Yes, Jeffrina. Okay. Is it clear? Okay. Thank you. That means you are understanding good, right? My speed is okay. Can I increase the speed or should I decrease or I should go in the similar manner? Yes. Yes, sir. The speed is okay. Fine, fine. Yashila. Okay. You are understanding, right? Okay. I want answers from everyone. Here, 7 participants are there. That means I think will be 6 if you leave me. Prasanna, Pugal, Tangaraj. Okay, this speed is fine. Okay, okay, okay. Then, okay, I'll continue. I'll continue from here. This is the homework one. Now we'll go into the next topic, that is linear and types of circuit elements. Before this, starting, if I start, it will take some time. So before starting this, I will just tell you one small topic. What is planar network? What is non-planar network? Okay. This will start from tomorrow, because by today, if we start also, we'll not complete, because I want to take more problems also in this. So I'll tell you what is planar and what is non-planar network. Yes, we will see. Planar and non-planar networks. Planar and non-planar networks. This will be important just for basic understanding. Mostly no questions will be asking in your gate. Why, which is planar, which is non-planar. But in statements you will be reading, this is valid for only planar networks. This is not valid for non-planar networks. So you should know before reading any statement what is planar, what is non-planar. Fine. Now, network that can be drawn on a 2D plane, that can be drawn on a 2D plane, is called planar network. Is called planar network. In this network, and the networks which can't be drawn on 2D, it is called non-planar. The network that can't be drawn on a 2D plane, okay, are called as non-planar networks. Fine. Now I'll give you an example. I will give an example. See. This, and one more example is, okay. Now, if you see these two networks, then you will see the difference of this jump. Okay, this jump, this whichever mark is there, that means it is crossing over. It is crossing over. There is a jump here. So this branch makes the network, this branch, okay. This branch makes the network. It is can be drawn only in 3D network, 3D plane, sorry. So that means it is this branch can be seen only in 3D plane. This branch makes the network 3D. So it can't be drawn in 2D. Can't be drawn in 2D. So if you are not able to draw in 2D, then it is called as non-planar networks. Non-planar networks. Fine. And if you see this, there is no jump, nothing, everything is clear. So this is planar network. Clear? What is the difference between planar and non-planar? Yes. Is it clear? Now, I just want to ask few things. If you are having any doubts, you can ask me. I'll answer. If you are having any doubts, please ask me. I'm ready to answer. Please. Please. Tell me. Yes. If you are having any doubts, please ask me. Everything is clear then? Okay, Pugal Tangaraj, it's clear. Okay, for others, please reply. Please. Okay, Jafrina, Arshina, Yashila, clear. Okay, if you are clear, then I want to ask you questions. Please reply. What is the difference between EMF and potential difference? Lavanya. Okay, tell about EMS, sir, once again. Okay, I'll tell you, but before that, I want to know answers from others. Others said it is clear. So just tell me, yes, what is the difference between EMF and potential difference? Except Lavanya, everybody others, please answer. Because Lavanya is having doubt. Please. Please answer. Except Lavanya. Everybody, please. Reply, no problem. Nothing will happen. Even if it is wrong, I told you if it is wrong only, that means you are going in a correct path. That's what I feel. Because if you are doing something wrong here, you will not repeat the same mistake in exam hall. Please. Yeshila, Arshia, Jafrina, Pugal Tangaraj, Prasanna, please reply. Yes, I'm getting no answers. Means you are typing very big or what? Just a little difference only. I don't want clear cut answer. Just little bit where I can understand and you can understand. No answers? See, when I'm asking, please reply. If you know, you tell no. I know, sir, I will answer. If you don't know, it's fine. It is fine. Tell, sir, I'm not clear. That is why I'm not answering. But if you're not at all texting, if you're not at all replying in chat box, then how I can know that it is clear or not? Please reply. How I can know, please? See, I'm not getting any replies. That's not good. Okay, Pugal Tangaraj. Potential difference is a dissipated energy, sir. Yes, yes, yes. You are correct. Yes, this is what I want. Whatever you know, please, you reply. EMF is energy supply. Good, good, good. That means you are answering correctly. Prasanna P told EMF is energy supplied. EMF, yes, I and anybody others answering? Yes, you are correct. That means, yes, Lavanya, I'm telling one more time. EMF is something the total energy supplied by a source. Okay, total energy supplied by a source to drive current through the circuit. Okay, that is the exact meaning. Whatever Prasanna Pugal Tangaraj told, it is absolutely correct. EMF is the energy supplied and potential difference is the dissipated energy. It's fine. The total energy supplied by a source to drive the current is called EMF. Potential difference means energy consumed or dropped across an element or between any 2 points, because potential difference means you will measure across 2 points. So across 2 points, if there is a drop of voltage, that is called potential difference. Fine. Clear? Is it clear? Yes, please. Lavanya, is it clear or shall I? Yes, sir. Understood. Okay, thank you. Yes, yes. And everybody are good. Everybody are attentive, and it feels good for me also, because whenever any teacher, it's not only me, whoever is teaching, after his teaching of 1 hour or 1.5 hours, if he's asking some questions, if students are able to answer, it feels good. It feels good. So I'm very happy. Whatever I taught to you, you are learning, you are understanding. And please tell who is from double E and who is from triple E. Sorry, ECE. Who is from ECE, who is from triple E. Okay, Pugal Tangaraj is from double E, triple E. Lavanya triple E. Yeshila triple E. Jeffrina ECE. Arshina ECE. Prasanna triple E. So I think how many? So that means Prasanna ECE. Jeffrina and Arshina are from ECE. Prasanna is triple E. And Yeshila is triple E, Lavanya is triple E, Pugal Tangaraj is triple E. 1, 2, 3, 4 are triple E, 2 are ECE. Okay. And it's good. It's good. No problem if you are from ECE or double E background. But for ECE, you are getting 2 to 3 marks extra as compared to double E from network theory. And I'm also going to teach control systems, engineering mathematics, general aptitude. And for double E students, I can teach double E or triple E, whatever it is. Double E, why I'm telling is because in GATE, there is no way, nowhere mentioned it is triple E. Triple E students will write the double E exam. Yes, double E GATE paper. So that is why it's every time we'll be calling it as double E. So that is the reason why it is coming out like that. I'll be teaching for triple E machines, power systems, and power electronics. I'm able to teach. We'll see how it is going and everything. Yes, it's good. You are answering everything. Now, I want only one thing is you please answer whatever questions I have given. Please. And you are in WhatsApp group. So if you are having any doubt, you can do a text message. You can share a photo, something. If you are having any doubt, if you have stuck somewhere, I will answer. Fine? Fine? Is it okay? Yes, yes, yes. You are replying very fast. Yes, it's good. Okay, we'll close for today. Tomorrow we are going to see types of elements. Done? Sorry, we are going to see what? Types of circuit elements. That is active element, passive element, linear or non-linear, everything. Tomorrow's topic will be linear and non-linear, active and passive, bilateral and unilateral, lumped and distributed, time variant, invariant. I've given everything. We'll discuss everything tomorrow. Fine. After that, we'll go for resistor, temperature coefficient, resistor, inductor, capacitor. All these things we'll complete tomorrow. All these basics. Then slowly, we'll go into the questions. These are the basic questions which we have discussed. And if you know these things, then we are going further into network theory in depth. Then all these things will be very useful. If you don't know the basics properly, if you don't understand basics, then it's no use of going into deeper. So that is the reason why I am doing even a basic question. P is equal to VI. Fine. Okay. Thank you for today. We'll meet tomorrow again at same time. And time will be mentioned in the WhatsApp group. Okay. Please come in time as usual. You have come today. Tomorrow also please be come on time. Thank you. Bye. Have dinner. Good night. Bye. Thank you. Bye.